Hello everyone. Today I am going to present our project CuraAI, a retrieval-augmented generation-based medical chatbot designed for both doctors and patients. So the system is powered by the MIRIAD Dataset and is built to provide accurate evidence-based medical answers in two different styles: technical for professionals and simplified for patients. So what is MIRIAD? MIRIAD stands for Medical Instruction and Retrieval Dataset. So it's a large-scale, high-quality medical dataset containing 5.8 million question-answer pages, all grounded in peer-reviewed literature. So it's specifically designed for retrieval-augmented generation, which means it's perfect for building medical AI systems that are both accurate and reliable. So why MIRIAD matters? So one of the biggest problems with large language models in healthcare is hallucination. So giving confident but incorrect answers. Raw medical literature is also too long and noisy for efficient retrieval. So Myriad solves this by breaking down scientific text into concise, quality checked question and paste, making it easier for AI to retrieve and use relevant knowledge accurately. So how Myriad was made? Let's look into it. So the data set is built from around 2.5 million medical papers processed down to about 8,94,000 high quality documents, and each passage was turned into a question and answer page using LLMs, followed by multi-stage quality control including rule-based filtering, GPT-4 for annotations, a Mistral classifier, and expert human review. So the end result is a clean, compact, and reliable dataset ready for AI use. And what were the key results and takeaways? So when combined with a retrieval augmented generation system, Myriad outperforms using raw text by up to 6.7% in accuracy, and it improves hallucination detection by 22 to 37%. So it has been tested across multiple medical benchmarks like MED-MCQA, MMLU MED, and USMLE style questions, proving its reliability. So let's jump into our project scope. So what is the aim of our project? So our project CuraAI will be an AI powered chatbot that supports two modes: doctor mode, which uses precise medical terminology for professional use, and patient mode, which provides the same answer but in a simple, easy to understand way. So the system will be text based initially with voice features planned for later, and it will store user history for the future references. And the system will use the Myriad dataset and trusted Indian medical sources implemented through a retrieval augmented generation pipeline for accurate evidence ground answers. How Myriad enables CuraAI. So Myriad provides us with compact high quality retrieval units, which makes our RAG pipeline more efficient and accurate. We'll use the same embedding and retrieval strategy as in the original paper, but optimized for CPU usage. Additionally, we'll add a pre-processing and post-processing layers to handle casually or high technical inputs depending on the user mode. So who are the users of our project? So CuraAI is designed for multiple types of users: doctors who need quick evidence-based answers, patients who want easy explanation of medical terms, medical students who can learn from both answer types, researchers who want clean relevant data, and general practitioners or primary care physicians who can get quick guidance during patient care. So what is the tech stack we are using in the project? Let us look into it. So the tech stack. So we are building this with React.js for the front end, FastAPI or Flask for the backend. For AI, we will be using BG large embeddings, LLaMA 3.18b for generation, Gemma 2b for rephrasing and simplification, and the database will be MongoDB, and for vector search we'll be using FAISS, and the main dataset will be Myriad combined with Indian medical guidelines. Next, the architecture diagram. So this diagram shows a pipeline starting from the user input through pre-processing, embedding retrieval from the vector database, passing context to the LLM, post-processing, and finally delivering the answer. So each mode, doctor or patient, passes through slightly different pre and post-processing layers to tailor the language of the response. So our use case diagram highlights the interaction between the two main actors, doctors and patients, and how they use the chatbot to get answers, view history, and switch between modes as needed. So let us look into the workflow. What is the workflow? So the workflow starts with the login and selecting the mode, and the input is processed, either simplified or kept technical, then the embedding and matched with the relevant data in the vector database, and the LLM generates an answer which is post processed, and the final response is shown to the user and stored in the MongoDB. So this is the workflow of the CuraAI, and we have relied on the MIRIAD Dataset, Indian medical guidelines from institutions like ICMR and AIMs, Hugging Face models for embeddings and language generation, and vector database like FAISS to implement the retrieval systems. And this is a project team together. We have worked on integrating data resources. We are working on the RAG pipeline and designing a system that is both medically accurate and user friendly. That's it. Thank you.